So once you generate the cost grid, the cost distance grid, the cost backlink grid, then you can utilize those as input rasters along with the destination grid or a destination point to calculate your optimal path raster or your optimal path line. Now you use optimal path as raster to identify a one cell wide raster least cost path. And the thing I struggle with this analysis is because the output, one cell wide, is not very wide. It sometimes can be hard to see in the output. So I prefer to use optimal path as line to identify a polyline feature along the least cost path. Now you can generate different types of paths with both of these tools, depending on the output path type you select. If it's each cell, then you can have multiple paths calculated that can overlap. If it's each zone, you can only calculate one path per zone and they don't overlap. And then last, if it's best single, it's the single least cost path. So if you look at the example on the right, if you notice the very bottom row on the cost grid goes from left to right, 1, 2, 2, 1, 3, 4. And so notice that just above the 3 is a 2, which is lower cost. And so when you generate the output, which is the optimal path as line or optimal path as raster, notice how the path jumps up to take the least cost path through the cell valued 2 rather than the cell valued 3. Now, the least cost path analysis is about identifying the least cost raster or line path from source to destination. Least cost corridor analysis is about identifying the least cost path or raster swath between two or more sources. So you're not just looking for a single line, you're looking for often connections between multiple input sources, but also a larger swath or corridor in which the least cost occurs. And so you can use optimal region connections to identify the optimal connections between two or more input regions. It outputs a polyline feature connection that connects all of the input sources. And you can use corridor to identify the optimal swath of cells between two input regions. So the output is the sum of multiple accumulative cost rasters, of which you can select a swath of cells that satisfy a minimum threshold. And if you look at the example on the right, you can see I've got two inputs, input 1 and input 2, and then I've identified the least cost swath of cells between those two. And you can imagine utilizing that if I've got two habitat areas and I don't expect all of my species to take one single line file path between my two zones. I might do a corridor analysis so I can identify the swath of cells where I expect animals to migrate between the zones. And so we use corridor analysis to answer questions like, what are the most likely wildlife corridors between two large parks? What is the optimal route for a new high-speed railway? Or what are the most likely migratory routes for early man? And we can use our general analytical process, question, inform, analyze, decide, and present, to construct a corridor analysis process that starts with step 1, defining the project criteria. Step 2, map, model, and sum all the costs. Step 3, perform a least cost path analysis. Step 4, refine your analysis. And step 5, quantify and visualize your optimal path or paths.